All right, so now that you know how to find x by yourself on a shape, we're going to now go through and learn how to identify which proportions would in fact prove that something is in fact similar. So what we've got here is two polygons, and we want to know if the polygons are in fact similar, and we're going to use ratios to prove it. Notice that we're not trying to find a missing side. I have 7, 9, 14, and 18. There's no unknowns. I'm not trying to find an unknown side. Right now I'm actually trying to prove that these are similar. So first, let's ask ourselves which side is longer, AB or AD. So over here, is AB or AD longer? AB is obviously longer. Now in the bigger shape, EF or GF. Is EF or GF longer? So it's obviously EF. What that allows us to do is see that this yellow side matches up with this yellow side, and that this green side matches up with this green side. Now I also want to remind you guys real quick over here that similar figures have the same shape, but they're different sizes, and that's the whole point over here. Now I do think that a lot of you could quickly realize that this one has a scale factor of 2, because if you take 9 times 2, we get 18, and if we take 7 times 2, we get the 14. Now even though the 14 is written down here, we know because it's a rectangle that that's also a 14, and we can see again the green sides are doubled. Now over here we have examples of proportions that prove that these things are similar, and so I'm going to walk you guys through right now how to identify that these things do in fact prove that they're similar. So the first ratio talks about AB with EF. It says that AB compares to EF. So far it's matching up red and red. Then it says over here that BC should match up with FG. Right here, BC does match up with FG. So since it correctly shows that the 9 matches this 18 in red, and that this blue matches this blue, this proportion does prove similarity. Now this proportion right below has everything filled in with numbers. So I could ask you guys, does this numerical proportion prove similarity? And all I'm asking, again, is side AB, it's the 9. Side AB is the 9. And then side EF below it is the 18. Over here, side BC, that's the 7. And side FG, that's the 14. So now with numbers, we want to just check to see, is this in fact a proportion? And I think you guys can easily see that 9 is half of 18. 7 is half of 14, and so both of these are a 0.5, and if that's the case, then we know that since 0.5 equals 0.5, that would be proportional. So first, again with letters, now let's try a different set. We're going to see first with letters and then with numbers that it is in fact proportional. So this next one says AB to AD. So now what it's saying is AB, so the top purple part, compared to this side red part. And so over here it's saying purple to red, and that's where we're getting the 9 to 7. It's saying side 9 with side 7, so purple to red. Now on the other side it's got EF, so EF, there it is in purple, and it's saying it's 18, and EH, which is right here in red, and it's saying that it would be a 14. So all we're doing right here is with letters, looking at the sides, and then we're just filling in the numbers. Now again, the whole goal is to check and see, is this thing a proportion? And right there, a lot of you see that 9 times 2 is 18, and 7 times 2 is 14, so they are equal. So yes, this is proportional. So now what we're going to do is I'm going to walk you guys through this select all. I have definitely seen on the SOL several questions like this to just check to see if you know how to determine if two shapes are similar. So for A, B, C, D, and E, what we're going to do is we're going to use the letters to try to just fill it in with the numbers and then verify that the number is in fact a proportion. All right? So all I'm going to do is I'm going to take, I'm going to erase this real quick, and I'm going to bust out my highlighter. And let's go through answer choice A. So A says AB over EF. So AB over EF. So they're saying from the smaller shape to the bigger shape, those things match up, and it's a 9 and an 18. And then AD is right here, that's a 7. And EH is over here, and we know that that is the same measurement, so it's a 14. So this is saying we're going to go from the smaller shape to the bigger shape, smaller shape to the bigger shape. So from a 9 to an 18 and a 7 to a 14. And right there, mathematically, we can see, you can cross multiply if you want to confirm that they're proportional. Or again, a lot of you can see just the times 2 and the times 2. And since this 0.5 does equal this 0.5, this does prove similarity. Now, at this point, I think it's going to be really helpful to see answer choice B and what would not prove that something is similar. So answer choice B, let me actually erase this stuff real quick. All right, here's what answer choice B is saying. Answer choice B is saying that if we go from A to B, so A to B, which is 9, and then we go AD, which is right here, 7, it's saying we're going to go from the top part to the side, so top to side. If B was an answer, we're looking for top to side, top to side. But let me just make that blue real quick. That was the top, and this was the side. So instead, though, EH is the yellow side right there, which is which would be 14, and EF is the blue side, and now it's here. And you guys can see that the yellow and the blue switch spots. And right here, mathematically, it's not going to be the same. If we cross multiply 9 times 18, 9 times 18, we get 162. Now I'm going to do 14 times 7. I don't get 162, so we know that these fractions, they are not equal to each other, so this does not prove that these are proportional. Now let's look at answer choice C. Answer choice C says from B to C, so let me erase real quick. So from B to C, and that would be right here in blue. So B to C is in blue, that does measure the 7, and then it's comparing FG. FG is over here, which is the 14, so it does correctly match up the side with the side. Okay, so far so good. Now for CD, CD is over here, and it's going to be, so let me actually fix these colors, because those should be the same color. All right, cool. So yeah, so those right there do match up. That side does match with that side. And a 7 does double to be a 14. Now it's saying if we take from C to D, which is right here, is that the same for DH? Now D is right here and H is here. So DH isn't even a side. That's not applicable. DH isn't even a side. And because DH isn't even a side, that definitely is not going to prove that these are proportional or similar figures, okay? Now let's look at the last two. The last two are obviously already circled, and they do show similarity. Let's prove it real quick. This says AB over EF, so AB matches up with EF. The 9 does double to turn into the 18. BC in green does double to turn into 14. And because when we cross multiply, let's double check by cross multiplying. So I've got 18 times 7, boom, 126. And now I'm going to do 9 times 14. Same answer. So once again, they're proportional, and you guys can easily see that 9 is half of 18 and 7 is half of 14. So we are going to select this one. And now for the last one, I'm just trying to teach you guys, if it gives you a bunch of letters, how to find the numbers and then check to see if they're proportional. Okay, so for the last one, side DC is right here in blue, and then side CB is going to be the height, and so it's saying from base to height. It's comparing base, which is 9, to the height, which is the 7. So now we're going to check to see if the other one does its base to height. It's going from base to height. So is HG the base? Yup. And is GF the height? Yes. If we turn this thing sideways, if we knock it sideways, we would see that long HG right here, and then we would see the 14 GF right there. Okay. Yes, 9 times 2 is 18, and 7 times 2 is 14, so this is proportional. And that's how you can check to see which ratios down here with letters prove similarity. Now this next one, it's not tricky, it's not confusing at all, but you see that 1/3, and I feel like you're going to think it's confusing, but it's not. Let me just go ahead and actually get your attention right here on the base of the triangle. Y'all, what do you got to do to 15 to get 5? What do you have to do to 15 to get 5? We have to divide by 3, right? Well, we've talked a lot about this. We've talked a lot about dividing by 3 is the same as multiplying by a third. So the scale factor here is a third. We got to take a third of 15 to get to 5. If we take 36 and divide it by 3, or take a third of it, we do get 12. And if you don't believe me, I'm just going to do 36 divided by 3. Boom, I get the 12. So I need to take a third of this to get 13. A third of n would be 13. Now over here, when solving this, think back to what you guys would do. You'd just times it by 3 and times it by 3. And what that does is tell you that the n has to be 39. So in blue, what we're doing is we're actually going from the smaller triangle to the bigger one by saying, so 12 times 3 gives me this 36, 5 times 3 gives me the 15, and now 13 times the 3, we just did it mathematically, when we solve it, it proved it had to be a 39. So even though we take a third of this triangle to make this triangle, when we solve it, we're multiplying by 3, 13 times 3. It's just 3 times bigger over here to get the 39, okay? So a couple different proportions that we could set up. Once again, let me just erase this. I'm not sure how you see it. I can't get inside your head to see how you see it. But what some of you do is compare big to small. So you see that the 15 matches up with the 5. And you're going from big to small, so you're saying 15 to 5. So then n to 13. So 15 to 5, n to 13. When you cross multiply and divide, you're going to get 39. Now, some of you don't see it that way. Some of you see that 36 matched up with the 12 from big to small. You saw 36 with 12, and then that n matches up with the 13. So you can use the 36 and the 12, or the 15 and the 5. It doesn't matter, because when we cross multiply and divide, we're still going to get 39. A final way you might see this, and honestly, I think this might be the way I see it. I see that my unknown right here is the slant that goes with this 15 on its own shape. What I mean is the slant compared to the base, that the n goes with the 15. So if n goes with 15, then you'd want to say that 13 goes with 5. The slant goes over the base, and there's the 13 and the 5. And once again, y'all, when we cross multiply, I'll just do this last one. 15 times 13, boom. When I hit divide by the 5, I get 39 yet again. So there's a lot of different proportions that you can see, and I recommend setting up a proportion. Also, if you saw the scale factor, again, the scale factor is a third. A scale factor here is 1/3. And when we take a third of n, we get 13. So to find n, we take 13 and just turn around and multiply it by the 3, and boom, we've got that it would be 39. So it's up to you if you're going to be a scale factor person or a proportion person. And again, for proportions, there's lots of different ways to set it up. Let me show you guys real quick what you don't want to do. Here's what you don't want to do. This is really, really, really critical. So let's say you see that 36 goes with 12. So let's say you're this person. Let's say you see 36 goes with 12, and you're like, yeah, I've got my 36, and I've got my 12. And that means you're going from the bigger one to the smaller one. What you don't want to do is now say that the 13 is over the n, because what you're doing is now putting smaller over bigger. And over here in red, you started out with bigger over smaller for the ratio. So don't switch it up. Just make sure whatever you set up first with the first ratio, you then keep it consistent with the second one. And so then once again, if you want bigger to smaller, we want n over 13 here. And that would be the proportion we set up with the equal sign in between, not this one. Okay? All right, now let's flip over. And we're going to take a look at the similarity statement off to the side. We're told that triangle PQR is similar to triangle DEF. And I wanted to remind you guys that this is what the similarity statement would look like. This is literally saying the exact same thing, that triangle PQR is similar to triangle DEF. The question here is asking which describes the relationship between the corresponding sides of the two triangles. Once again, folks, there's no X. I'm not trying to find an unknown. I don't think any of you see a scale factor from 4 to 10 or 6 to 15. It's not asking you to find any unknown sides. It's just asking which here correctly shows corresponding sides. So let me just walk you through it, and let's take a look at A. A asks if PQ is worth 4. PQ is worth 4. So far, so good. DE should be a 10, not a 15. So they're trying to say this yellow side, it should match up right here, but it should be a 4 and a 10. So right here is the right answer. Here's the part where this side definitely matches up with this side, and a 4 matches up with a 10. That's why this is the right answer, okay? Now let's look at answer choice C real quick, just so we can rule it out. Answer choice says that, answer choice C says PR should be 15. Well, PR does not equal 15. PR does not equal 15. It's automatically out. Right here, again, PQ was 4 and DE was 10, and it correctly shows that those sides corresponded to each other. The last one would say PR. Let me just erase this real quick, sorry. The last one is saying PR is 6, so boom, it does have that PR is 6. And then it's asking for DF, like DF does correspond to it, but 6 corresponds to 15, not to 10 like this one says, which is why that one's also out, okay? So this one correctly shows that PQ and DE are corresponding sides, and it correctly shows that the 4 and the 10 are the measurements for those corresponding sides. And that concludes this video. Thank you.